Good day, everyone. Today, we are going to use one of the most important theorems in mathematics, which is the Pythagorean theorem. It is a powerful tool used to solve problems in geometry, trigonometry, and even real-life applications. This Pythagorean theorem is named after the Greek mathematician Pythagoras.
In the Pythagorean theorem states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. For you to better understand the statement, in this figure, the hypotenuse, which is denoted by C, we all know that the hypotenuse is the side opposite to the right angle. It is denoted by C, and the legs are A and B. It is said that the square of the hypotenuse, C squared, is equal to the sum of the squares of the legs, which is A squared plus B squared. Now, we have the formula for the Pythagorean theorem. C squared is equal to A squared plus B squared. Or you can just simply say C is equal to the square root of A squared plus B squared to remove the square of the hypotenuse.
Now let's have an example. In a right triangle, the legs measures 3 units and 4 units. Now the missing is the hypotenuse. Let's use the formula C squared is equal to A squared plus B squared. Now substitute the given. Let's assume A is equal to 3, so 3 squared plus the next 4 squared. Okay, so 3 squared is equal to 9 and 4 squared is equal to 16. Now C squared is equal to 25. So let's remove the square of the hypotenuse. C is equal to the square root of 25. Therefore, the hypotenuse measures 5 units. Now let's try another example, but right now, the missing is one of the legs. So in a right triangle, this is A, B, and then C. C is equal to 13 units. And A is equal to 5. Now let's try to find B. Using the formula, C squared is equal to A squared plus B squared. Missing is B. So the only thing that we will do is to transpose A squared so that B squared will have to remain on this side. C squared minus A squared is equal to B squared. The next thing that we will do is to substitute the given values. So C is equal to 13. 13 squared minus A 5 squared is equal to B squared. 13 squared is equal to 169 minus 5 squared is equal to 25 is equal to B squared. 169 minus 25 is 144 is equal to B squared. We are not done yet. We have to remove the square of the B. So B is equal to the square root of 144, which is B is 12. Therefore, B measures 12 units in this figure. Now let's see why this theorem works. Imagine a square built on each side of the triangle. The areas of the squares on A and B add up to the area of the squares on C. So let's draw a square on each side of this figure. Imagine this is a square, and we all know that a square have the same measurement on each side. Imagine this is 4 units and this is 5 units on each side. It is said that the areas of the squares on A and B add up to the area of the square on C. So to get the area of this square, we all know that the formula for getting the area of the square is A is equal to S squared. So in this square, the area is A is equal to 4 squared, which is A is equal to 16 square units. So this is 16, and this square, A is equal to 3 squared. Therefore, A is equal to, this area has 9 square units. And this square, A is equal to S squared. A is equal to 5 squared. Therefore, this square has an area of 25 square units. So to add this square, two square, A and B, 9 plus 16 is equal to 25. This square must measure or have the area of 25. And yes, this square has an area of 25 square units. So this theorem works.